When people talk about space exploration, they mostly discuss humans on the moon or life on Mars. But today I want to talk about Mercury and how studying this tiny planet helped us understand gravity.
Motion of planets around the Sun is an ellipse that gradually changes its orientation over time
Due to gravitational field,
of other bodies.
this is called precession of the perihelion. But when Mercury's precession was calculated using Isaac Newton's laws, the answer was always found to be slower than its actual precession. No one could explain it at the time. Then in 1950, Albert Einstein published his theory of general relativity, which stated that
Mass curves space-time.
space-time is 3 dimensions of space and 1 dimension of time woven together in a single fabric. It's kind of like a sweater.
All objects travel along space-time.
He found out that his equation was the same as Newton's, but with an extra term. This term becomes almost zero when the planet is very far away from the Sun. But Mercury is much closer to the Sun, so this difference becomes very noticeable. This extra term explained why there was a significant difference in Newton's calculations and the actual precession of Mercury's perihelion. What this means is that the Sun's curvature in space-time has a very noticeable effect on Mercury's orbit, and that is why it precesses faster than other planets. All of this is really cool to me, but I bet a lot of you might be thinking, I don't live in outer space, general relativity doesn't matter in my life, so why should I care? Well, if you think that it doesn't matter, you're wrong.
GPS or Global Positioning System relies on general relativity to function properly. There are 31 GPS satellites that orbit the Earth and they broadcast their location and what time it is.
These satellites contain super accurate atomic clocks. Now, relative to someone outside of a gravitational field, clocks inside the field tick slowly, which means that time runs faster up in those satellites. The GPS system has to take into account for this difference, otherwise our location could be off by up to 10 kilometers. If Google Maps ever got you somewhere on time, thank Albert Einstein.